Hello and welcome. Let's see one more example of DFA type 10. Construct a DFA that represents set of all strings that contains even number of specified symbol. For example, DFA for the set of strings over the alphabet A, B that contains even number of A's. Now before starting to construct the DFA for this language, remember that if any symbol is not present on that string, then that symbol is considered as even. For example, in string epsilon, both A and B are not present, therefore this epsilon represents even number of A and B. Similarly, the string A considered as odd number of A and even number of B, since this B symbol is not present in this string. Similarly, the string B indicates even number of A and odd number of B. Now let's start to construct the DFA for this language. Here we start with the starting state Q0. This Q0 is the starting state and hence does not read anything till now and represents only epsilon till now. Therefore, Q0 state indicates even number of A's and even number of B's. But for our language, we do not have to consider the number of B's, so we do not write even number of B's here. Now, what if the machine reads a symbol A in Q0 state? That means adding one A in even number of A, which makes the number of A to odd. Therefore, we switches to the new state Q1 that indicates odd number of A's on encountering the symbol A in Q0 state. Similarly, what if the machine reads a symbol B in Q0 state? In that case, the number of A still remains same, that is even number of A's. Therefore, we make this transition on encountering the symbol B in Q0 state. Similarly, what if the machine reads a symbol A in Q1 state? In that case, the number of A remains same, that is odd number of A's, and only the number of B increases. Therefore, we make this transition on encountering the symbol B in Q1 state. Finally, what if the machine reads a symbol A in Q1 state? That is adding one A in odd number of A's, which makes it even number of A's. Therefore, we switches to state Q0 on encountering the symbol A in Q1 state. Here we have to accept all the strings that contains even number of A's. Therefore, we make Q0 state as a accepting state. As we see, we define all the possible transitions. Therefore, this is our required DFA. That's all in this lecture video. If you have any queries, then please leave the comment, and thank you for watching this video.